To do this, first of all, you have to open X Manager Enterprise 3. In that, open X Start. Here we are having a session. Whatever the session you want, you can place. And host is the local, whatever the server system we have, that IP address and protocol you have to assign as SSH, and username, whatever the user is assigned to you, that you have to give, and password based on your institutions what he is given that. And here you have to select the execution command as Linux type 3 and click on run. Then you will get here as your user is linked with the local host, and here you have to use three commands. One is CSH, and second one is the source command file, and after that you have to assign design manager. Now here you have to use a file. In that file you have to use new and select a project, and here you have to give some project name. Here I am giving my project name as a Raja demo, and here in the technology part you have to assign some standard library which was provided in our Mentor Graphics tool. Click on that, browse, and here you have to use an up arrow up directory to get software pro folder. In that, go for Mentor Graphics. In that, Foundry. In that, GDK you have to select. Under GDK, fix is setup once again, and after that you have to use ICReflips. It is a reference library file you are having. That file you have to select. After that, go for the technology library, which is here the third folder we have. Technology library you have to select. In that, generic 13 is a standard package that is selected here as a path, and you have to click on OK. After that, in the manage external logic libraries, here no path is assigned. Here you have to add standard library also. So click on add standard library, then you got the path here, and click on OK. Now whatever the project you have created as Raja demo, under that you have added two libraries. One is technology library and one more is the generic library. In both of the libraries we cannot change anything. That's why you have to create one local library to do our all experiments. That's why right click on your project name, go for new and select the library and give some name. Here I am giving as a local, as library name is a user library. So here in the local library I have given as a local. This plus symbol I have expanded, nothing is in that folder. So in this we have to create two cells for each and every experiment. So right click on that local library and go for the cell, new from that cell. Here you have to take two cells. So click on that cell. Then give the cell name. Here one cell is for the schematic and another cell you are designing for the test bench. So schematic cell is when we have assigned, when you expanded the plus symbol under local, you are getting that one cell name. See here. So inverter schematic is assigned here. Again we are going for a cell, and that cell we are taking for the test bench waveforms, that is for analysis and simulation purpose, to view the waveforms also. So here I have created two cells under local library. Whenever you want to do anything, that is one more experiment if you want to do, then you have to select two more cells, one for the schematic and the second is for the test bench waveform. So here inverter underscore schematic is used here for designing of our circuit and generation of symbol, and test bench waveform is used for the analysis purpose, to do simulation and to generate the waveforms. We are using the two cells here. So first of all we will use the inverter schematic cell to design our circuit and to generate the respective logic symbol for that designed circuit. Here we are using a CMOS inverter. So I am using here right click on the schematic and go for the schematic and click on OK. No need of changing its names. So here you are getting some workspace. It looks like a breadboard. In that you have to design that CMOS inverter circuit. So for that you have to take all the components. In the CMOS we are having the PMOS and NMOS combinations. In pull up we have the PMOS, in pull down we are having the NMOS transistor. To let those components on this place, we have to click on instance folder, which we are having in here left side of these icons. This is the add instance folder. You can use this folder, or you have to click on I button on your computer keyboard. Then automatically add instance folder will be open. In that add instance folder, whatever the standard library we have, generic 13, click on the double click on the generic 13, automatically you are getting one folder called symbol. So click on symbols. In that you have to take PMOS and NMOS symbols. First select the PMOS symbol, place here and click on escape. Otherwise you are getting more and more number of transistors. After that, pasting that, right click on that and you have to change its width. For PMOS you have to assign 0.56 micrometers of width. So you have to change that by right click on that and open the edit object, and you have to paste to 0.52 micrometers. After that you go for once again instance folder and take the NMOS symbol and put in the pull down place. Again same, here also you have to change the width. Take the width as 0.26 micrometers. So you have to assign as 0.26 U only. After that, to assign input and output ports, here in the left side we are having the ports. Take add port in for the input port and add port out is for the output port. Again you have to paste that and click on escape. Again you have to take the output and paste that, click on escape. After that, on the top we have to assign VDD and down you have to assign the ground. They are available in the right side library space. Go for that and use generic library. From that you have to take VDD, keep on top, and take ground and keep in the bottom side. Now whatever the required components are there, all are placed here. To view all those you have to use the view all or fixed frame. Then you are getting this, all these will be connected together as per our circuit diagram. To connect them, you can use these wires connections, or you have to directly drag those line points. So if you are connecting any wrong connections, then automatically you can use U, which is undo. U is nothing but undo. That is, you are going for the previous step. Then automatically you can connect remaining assigning connections. After that you go for the name changes for the input and output ports. Same, right click on that, go for the edit object. In that net name you have to change as per your requirement. You can use any alphabets, or you can use directly input or output, whatever it may be the names you want to give, those you have to give. After that, here in the MOSFETs we are having the 4 terminals. In the 4th terminal is called substrate terminal. You cannot leave that without connections. So compulsory you have to connect them. So in under NMOS that is connected to the ground, and in PMOS that should be connected to the supply voltage. After that circuit is completed, you have to save that one. Click on check and save. Then some report is generated. In that report, if there is no errors, your circuit is good, and you have to continue for next one. Then you have to generate a symbol. For that you have to go in the top one, file, edit, and then you are having the add. Go for add and click on generate symbol. So in that, select these ones and take a shape what you are required. Here I am designing in the inverter, so I took buffer, and in the pin connections output is an inverter, so bubble we are having, I have enabled the bubble, so some symbol is generated as per my requirement. That symbol is inverter symbol. Up to this the first cell work is completed. Only designing of circuit, schematic circuit, and generation of the symbol. Up to now, whatever the first work with the first cell, that was completed. Now what work we did, that is visible in this space assigned in the right side. So here it is the schematic and inverter symbol. Now for the analysis, I am going to test bench cell. Right click on that, go for new and take the schematic. In the previous, what I did in the schematic cell, same process we have to do here also. Go for I folder, and instead of taking the generic 13 and the symbol, I have to go for the local, and I have to take the symbol from the schematic cell which I have designed earlier. Now same input ports and output ports I have to assign to that symbol what I have designed as an inverter symbol, and I have to make the connections. But to analyze what is the input I am giving and what is the output I am getting by the respective input value, for all those I have to give here some input source value, and also in our circuit we use VDD, but what is the value of VDD I have not assigned, because all we were giving here. And before that I have to change the net names for the input and output as per my requirement. I have given output as out, and input name is terminal name is in I am giving. And after that I have to assign the input source and also VDD. For that in the right side of the window we have library. In that you have to take source library. Sources library is available there. I will show in clearly. See the sources library. From that you will take, and before that I took the VDD and the ground from the generic library. I have for input source also I require ground, so I took that one. After that go with the back icon, and from that sources library is available. From that sources library I am taking some pattern. So pattern is nothing but I have to give 1 or 0 something what is my requirement, that one. And for VDD value I have to give as a DC value, and I have to connect a positive terminal to the VDD and a negative terminal to the ground one. Similarly, positive terminal of a pattern is connected to input terminal, and it should be connected to the ground one. Here VDD value I am giving as 3.3 volts. It is a minimized CMOS voltage levels we have, that we are giving as 3.3 volts as a maximum logic 1 value, and here I am giving some pattern value as per my desire, and click on OK. That pattern is assigned here. After that click on check and save. Then if you are not getting any error, it is good, well and good. If you are having some warnings, you can leave that. Now go for simulation. Click on simulation in the right side and click on new design configuration, click on OK and OK. Then whatever the editable space in the background you are having, that will be changed here. See that. Now you have to use analysis. For this one we will do 2 analysis. Here I am going to click on analysis, disable the OP, and I have to do DC analysis and transient analysis. In that transient analysis you have to give the start time as 0 nanoseconds and end time is 1000 nanoseconds, and the delay interval should be 10 nanoseconds, and come to the bottom and apply that one. Again you have to use one more analysis, that is called as, what is that? DC analysis. For DC analysis, go for the DC, and here sweep type we have to select as source, and whatever the symbol we have, cross symbol, that you have to keep on input source value. How many number of sources we have? You have to take the number of sources there. We have only one source, so I kept that only one value V1, and I have to give the values as 0, 3.3 is maximum, and step variation is 0.1, and down apply and OK run you have to click. After that, here you will get simulation finished. Then your analysis and the way of process of simulation is well and good here. If it is failed, you will get as failed. Now you have to select the input terminal, symbol, and output terminal, and go to outputs is icon available at the right side. In that you have to give two analysis. One is DC, and take the type as default, and task you are plotting the waves, so take plot and click on add. Again you have to select the symbol. See here, symbol I am selecting, and for that type I am taking as an power, and click on add. In the similar fashion you have to assign one more analysis by selecting all. So select the transient and plot, click on add. Again select the symbol and go for the type as power and click on add, and come to the bottom. At there we are having apply, OK and run. You click on both of them. Then also we are getting simulation is finished is the result you are getting. After that, at the right side, when you are going down, here we are having a run option, run eldo. After click on that, you are finishing one more simulation is there. After that, to view the waves, you go for view waves icon. Here default generations of waveforms I have closed, and I am running once again. Click on DC. In the bottom we got the V in, run that one, double click on in both of them. You will get DC analysis of the input and output, and similarly for transient also. If we are giving 1, we are getting 0. If we are giving 0, you are getting 1. That is the inverter output. In this way you will design any logic circuit by using mental graphics tool very easily. So to do one more experiment, no need of creating new project and new local library. Only one time you have to create a project and a library. In that you have to create a multiple number of cells. For each and every experiment you require 2 cells. One is for the schematic, that is circuit design and symbol generation, and one more is for the analysis and waveform representation. In this way you can do your experiments by using mental graphics tool. I think all of you understood very clearly. Thank you.